we electrifying nearly 36,000 households in the village area. So this is our transmission line system. Most of the hydropower plant are located at the northern state of our country, northern part of our country, and major load consumer area is the southern part of the country. So we transmit the electricity from northern part to southern part by using 230 kV transmission line. Now 500 kV transmission line is under construction period. So after finished 500 kV transmission line, we transmit the power more smoothly from the northern part of the country to southern part low center. So this is our electric power is. You can see here the blue color is electric power come from the thermal power plant. A small red color is power from diesel generator for the remote area, not for the big city area. For the remote area and small town, we supplying the power by using diesel generator. So most of the power is come from the hydropower plants. So you can see that most of the installed capacity is we generate from the hydropower. So the second largest power is come from the gas turbine. And so now coming previous year, this year and coming year, we will more power increase from the solar power plants. So this is the energy from the various power plants. So most of the power come from the hydropower, but coming year we also increase from solar. This graph shows the installed capacity and generation and consumption, power consumption. So blue color is mentioned installed capacity for the total power plant, and red color is the total generation from the power plant, and green color is consumption, load consumption for the whole country. This is our generation based load gas for this year September. So you can see the thermal power owned by state enterprise and MPP power from MPP thermal as we use as the base load. This year we introduce a new type of the thermal by using liquefied natural gas LNG. So you can also the portion of the power from LNG. Also we use hydropower and solar as a full mount to supply our people. Mainly power is also come from the hydropower. So you can see that some hour we have reserve power, but some hour we have no reserve power. This is the yearly increase of our load. You can see here. You can see here 2010 our payload is only lower than 1,500 megawatt. But now 2019 and 2020 our load became about over 3,800 megawatt. So our load increase between 1 decade is too much. We have many effort to supply this gap, to fulfill this gap. This is our consumption, load consumption. So most of the power go to the general purpose. General purpose means we use most of the energy for the household usage. In the industrial power usage is not so much like household usage. This means we need to supply more power for the industrial purpose to be our modernized country. This is a generation mix for the last year, 2019 and 20. According to this pie chart, you can see that half of the power comes from the thermal, and nearly half of the power comes from the hydropower. This is a blue color and light green color. So the coal-fired power plant is only installed capacity is only 120 megawatt. So left pie chart is a generation mix by installed capacity. Right pie chart is a generation mix by energy. So for the next year, we have the many solar power plants, about 29 solar power plants. To the installed capacity is 1,030 megawatts. So in next year, 2020 and 21, our solar power portion is began 30 or 14% in installed capacity. So this is for the future. For 2025, our generation mix began like this. So left pie chart is the conditional state. It means we get some if we get some support from the other finance institution like ADB and Orphan or something like this, we can increase our renewable energy ratio as 16%. If we can use only our own finance for unconditional condition, we cannot increase our renewable energy like the solar and wind portion. We can only increase 30%, about 1,440 megawatts. This is our plan for the next 2020 and 25. So this graph shows our hourly load pattern of our country for the power system, grid connected system, only grid connected system. In our country, off-grid system electrification is responsible for the other ministry. We are main responsible for the grid connected power system. So this graph shows the comparison between the 2020. You can see that in 2020, the peak load demand in November 18 is about 3,892 megawatt. So minimum day of this year, January 26, is only 2,822 megawatts. So it's very different. So the difference between minimum and maximum is about 2,480 megawatts. So this is a big challenge for our power system to be stable. So for the 1 day difference is about, for the whole year peak load difference is about 1,070 megawatts. For the whole year, maximum and minimum difference is about 2,480 megawatts. So this is a big challenge for system stability. Up to now, our renewable energy portion is only small portion. Next year, after finish 1,000 and 30 megawatt solar power plant, we have more challenge for this defensibility purpose. So this is a national grid map for the new solar power plant in 2011. You can see that our solar power plant is all over the country. So it means the distributed generation size. We supply the solar power all over the country by using 33 kV and 63 kV transmission line to the local 33 substation and 66 kV substation sites. This means our generation fluctuation from solar is we can flatten the fluctuation intermittent by using the distributed generation system all over the country, instead of one big solar power plant implementing. So this is the more clear figure for the new solar power plant. So you can see upper part of the country to lower part of the country, southern part, northern part, middle part, and the whole country we distribute the solar power plant, 23 solar power plant. Existing one is in the main pool, so total solar power plant is 30 solar power plants in coming year. So after finish this solar power plant, we can get the power from the 30 solar power plant. This is our imagination. The red color is the demand side. Red color is the demand side line. According to the energy from the solar, we have adjust our generation from the gas turbine, thermal power plant, and hydropower plant to adjust the intermittent and system stability. Also, we have to fulfill the requirement for the spinning result due to variable generation of the solar power plant. This is a big issue for our power system. We need to modify and we need to adjust and we need to cooperate all participants to be stable. So this is the location of our hydropower dam. We can implement the floating solar by using this big area, surface area of our hydropower plant. So this is the also big opportunity for the developer to implement the renewable energy project in our country. So for wind power feasibility, the feasibility study are now implementing by assistance of the Asian Development Bank. They are now trying to draw the wind density map wind zone for the wind power feasibility of our country. So Chiang, Magui, and Cayenne State are some feasible region to implement wind power. So this is some figure to implement wind zone. So thank you. Thank you for your time. Thank you listening for my presentation. It's very pleasure to make the presentation.
Thank you so much. Okay, all right. Thank you so much, Mr. Wen-Ment. Very much appreciate your detailed speech on the renewable grid connection in Myanmar. And again, I would like to express our gratitude for your participation on behalf of the organizing committee. And besides your speech, we've received so many really interesting questions from our audience, but since we are running out of time in this session, so I'm sorry to skip this part. And I think you can answer this question after your presentation, and you can find all the questions in the Q&A box. Thanks again for your participation.
Okay, thank you. I will try to answer the question in the chat box. Thank you.
All right. Thank you. Bye-bye, Mr. Wen.
Thank you.
Now, without further ado, let's get into the final session of the Myanmar journey. In this ending session, we're so glad to have Mr. Joseph and Mr. 𝗘𝗴𝗶𝗀 and Mr. Accurate in a panel discussion. Myanmar 1 gigawatt tender update in the large-scale solar. And Joseph is a partner of 𝗘𝗃𝗲𝗿𝗄, and he will be the moderator of this panel discussion. Hi, Joseph. Please take control of this panel discussion.
Thanks, Holman. I appreciate it. And that was an excellent session from Dr. Nguyen. I believe I don't have to show some of my slides because his were much better. So Your Excellencies, distinguished guests, and ladies and gentlemen, welcome to the ASEAN Clean Energy Week, and thanks for having us today for this session. First of all, I want to say, again, my name is 𝗘𝗃𝗏𝗁. I'm a partner at 𝗘𝘅𝗶𝗀𝗁, Thailand's oldest law firm, and we are celebrating our 130th year anniversary of being in business. We also have offices in Cambodia, Indonesia, Laos, Myanmar, and Vietnam, and I am the head of our energy practice. I want to thank the Leader and Associates team, including Holman, Oscar, and Zoe, and Wendy for making this such an excellent presentation over the last couple of days. And today, we will be presenting on the topic of Myanmar's 1 gigawatt tender updates and large-scale solar. I would like to introduce 𝗘𝗏𝗄𝗁, the founder and chief executive officer at Mandalay Oma, and also 𝗚𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 slide that was proving the case for the increase in solar from 2010 to 2020, and then the rapidly increasing demand. But I think we already saw slides to that effect. And so I thank Dr. Nguyen once again for such an excellent slide presentation. From my point of view, the Ministry of Electricity and Energy generates some of the best material, and I just hope that they post it so I can use it in my later presentations, and today was no exception. So with that, maybe I could turn and ask our speakers to give a little bit of background on themselves. And I'll start with 𝗚𝗃𝗏𝗏. I know we've seen